Now we need to know if our model or classifier is doing a good job or not. Spark offers some classes and methods to get some of the metrics, and we will have to write the code to get others. But these ones are easy, not difficult. Now I want to call your attention on this graph, where you can see on the x-axis the probability ranging from 0 to 1, and on the y-axis the number of patients that corresponds to each one of these probabilities. The green line means or represents the number of patients without cancer, and the red line represents the patients with cancer. If the probability is greater than 0.5, the model is going to predict that the patient has cancer, is positive, otherwise is negative. If your classifier is perfect, this overlapping area mustn't exist. But in the real world, this overlapping area is going to happen. This overlapping area means false negative, that the patient has cancer and was declared without cancer. And false positive is that the patient didn't have cancer and was predicted as having cancer. So in this false positive or negative is where the model fails. We are going to see more examples to make this clear. We have here two examples. In the first one we have a test data that tells us if the person is sick or is healthy, and your model or classifier is going to predict or diagnose as sick or healthy. So if this in the green checks, your model is doing fine, and in these red spots, your model or classifier is failing. So true positive means that the person is really sick and your model predicted or diagnosed as sick too. True negative is when the person is healthy and your model predicted as healthy too. False positive is when the person is healthy and was diagnosed sick. And false negative is when the person is sick and he was diagnosed as healthy. Based on the collected data, the confusion matrix is going to show you clearly the number of true positives, false negatives, false positives, and true negatives. Here there are another example that says your test data says is an email is a spam or is not a spam. And your model is going to send to the spam folder or send to the inbox. So true positives means that the email was a spam and it was sent to the spam folder, so that's good. And true negatives is that the email was not a spam and was sent to the inbox. That is good too. But false positive is that the email wasn't an spam, but it was sent to the spam folder. That's not good. And false negative is when it's a spam, but it was sent to the inbox. Which is worse, false negative or false positive? False negative for health is worst in the health case. A sick person diagnosed as healthy is really bad because the person is living and giving time to the sickness to become stronger with maybe fatal results. Instead, false positive for health, the person is going into further tests and stress but soon it will be discovered it was a false alarm. The health case when false negative is not okay, but false positive is okay, the model is called high recall. In the case of the spam, the false negative for spam, you'll get a spam in the inbox and you'll have to delete it. The false positive is worse for the case of the spam. A message sent for your grandmother who just learned how to do it will go straight to the junk and with a very high probability to be finally discarded. The spam case when false positive is not okay, but false negative is okay, the model is called high precision. So that depends on the case. Now let's review the last two metrics that are the faces of the same coin, the ROC and the AUC. The ROC means Receiver Operating Characteristics Curve, and AUC means Area Under the Curve. The ROC curve was first developed by electrical engineers and radar engineers during World War II for detecting enemy objects in battlefields after the experience in Pearl Harbor attack. Now we are going to compare three different classifiers. The first one that is a good one, the second that is not so good, and the third one that is a really poor classifier. We can see that the overlapping area in the good one is small. In the second that is not so good, the overlapping area is a lot larger. And in the last one is almost completely overlapped one over the other, right? So the overlapping area is too large. And you see here some small triangle in this left corner. That is the ROC curve, the behavior of the ROC curve under the three different classifiers. So in the one that is a good one, the curve is almost at the top left here. Now the curve is a little larger here, but farther from the top left and closer to this line of this triangle. And the last one is, this curve is almost the same as the line of the triangle. Let's see a little more in detail how the ROC curve and the AUC works. In the ROC curve, you have the x-axis, the false positive rate, and in the y-axis, you have the true positive rate. So you see here the formula. And so this curve is formed for the corresponding pair of values for the true positive rate and the false positive rate when you change the threshold. This is the threshold, and you move this threshold to the left and to the right. All the potential values of the threshold are going to change the values of these false positive rates and true positive rates. So each one of those points changing according to the threshold is plotted here. And we get this curve that is called the ROC curve. So the area under this curve is the AUC. And as we saw in the previous examples, a good classifier, this curve is very close to the top left, to this corner. So it's almost an square, right? The area under that curve is almost the square. So that's what we are saying. An AUC closer to 1 is a good sign. It's almost the area of the square. And we saw when it's a very poor, this curve is almost this line with the triangle. And the area of this triangle is, you multiply this side by this side, 1, and divide by 2, that is 0.5. So an AUC closer to 0.5 is a bad sign. It's almost the area of this triangle. These values are calculated by the Spark program, as we will see later.